Okay, so a couple things. So we are going to, this week, so we're wrapping things up. This is the last part of 6.4. We're going to go through, give you a little chance to work today. Tomorrow we're going to learn how to divide polynomials, workday, Wednesday. I kind of am hoping to do the test in multiple parts and start that on Thursday. Okay, so the test, here's how I plan on doing the test. Rather than doing one great big test, I'm going to break it up into parts. First part is going to be over properties of exponents and the stuff, polynomial graphs. Remember that stuff from 5.2? So we'll be over that. That's not a big deal. I'll put a practice test up, like today. Next one will be over polynomial arithmetic, which will be adding, subtracting, multiplying, and then after tomorrow, you know how to divide. So in dividing polynomials. And then the last one will be this kind of stuff. Be factoring polynomials. Okay, so break it into parts. That way, you don't have to retake maybe such a big test. Probably just a part of that maybe if you have to retake anything, you have to retake rather than the whole thing. Okay, so for today, how are we going to deal with this? How are we going to deal with this one? Hey, Brandon, let's get rid of that. Yeah, we want to see if we can factor something out, but can we? No. We can't. The coefficient is 1 here, so we can't take any numbers out, and there's no x in the last term, so we can't factor any x's out. So we're stuck with it the way it is, but that's all right. We'll split it in two parts, right? And we'll factor by grouping. Okay, so first group, what's going to be the greatest common factor there? Bailey, what do you think? What's the biggest thing I could divide out of both of those?
X cubed.
X cubed. Okay, good. And then what are we left with? Okay, so if I divide both terms by x cubed, what am I going to get? Brandon, what do I get from that first one? X to the fourth over x cubed is what? X. Good. And then negative 5x cubed divided by x cubed. Maisie, what's that going to be? What's going to happen if I do? I got negative 5x cubed divided by x cubed.
Yeah, so it'd be 5.
Oh, yeah, negative 5.
Yeah,
There you go.
yeah.
Okay, I didn't hear you, sorry. Yeah, you're fine. Okay, plus. Then the other group, right? Now the other group is where we got to be a little bit smarter about this. Well, we don't have to be, but we can take things a little bit easier on the other group. We know that if this is going to work, what has to happen in the other group, the second group?
X minus 5.
Okay, the x minus 5 has to be the leftover, right? So now all we've really got to do is just ask ourselves, can we make that happen? In order for us to have an x minus 5 left over, what would I have to undistribute? So in other words, what times x would give me negative 64x? Negative 64. And now let's just check to see that everything worked out. So does x cubed, would I distribute the x cubed? X cubed times x, x to the fourth. Check. X cubed times negative 5x cubed. Check. So far, so good. Negative 64 times x is negative 64x. Good. And negative 64 times negative 5 is what? That's going to be positive 320, right? So it does all check out. Good. So far, so good. Okay, next step. Now what do? I've got this thing grouped. What's going to be, Jasmine, what do I do next? I've got my left group and my right group. Is there a common factor that I could factor away from each one of those? There is. Okay? Well, let's. What are the factors in the first term? What are the things that are being multiplied? Factors are just the things that are being multiplied, right? X cubed and x minus 5. Okay. What are the factors in the second term? Okay, so were any of those the same in both groups? The x minus 5 was. Good. So we could factor that out, undistribute it. And then what's going to be left over if I do that? So we factored that out, so now it's gone. What's left behind? Oops. x cubed plus negative 64 would just be x cubed minus 64, right? Okay, good. So that helped a lot. Right now we got this down from this big ugly polynomial. We've broken it down into two smaller ones. This one's done. What about this one? Artist, can you think of a way to go further with that one? What do you think? Can I split that up more? How many terms in it? How many terms are in this factor? Two. Okay, so what's our strategy for two? If we have two terms, what's our strategy we're talking about for that?
Is that like the
It'd be like a squared.
Yeah. It's got to be a pattern, doesn't it? It's got to be a pattern. So does this fit one of our patterns? Which one does this fit?
A cubed minus B cubed?
Ah, it fits a difference of cubes, doesn't it? Right. We can write this. We could write the blue factor as x cubed minus, what's the cube root of 64? Well, of just 64 would just be 4, right? So that's x cubed minus 4 cubed is how I could write that. Okay, so then the x is like our a, and the 4 is like our b. And let's remind ourselves real quick, how does a difference of cubes factor? What's that factor into? A minus b times plus
AB plus
plus b squared. Good, okay. So we're gonna do the same thing, only with, instead of a and b, we've got x and 4, right? So then what are we gonna get? What's that gonna look like? Ariel, what's that gonna look like? So if I use that pattern for x and 4 instead of a and b, what am I gonna get? X minus, you're right. I know you're gonna say it. Our pattern is, right, if I have a cubed minus b cubed, remember that's gonna break up, it's gonna factor into a small factor and a big factor. The small one is just gonna be the a minus b. Big one is gonna be a squared plus ab plus b squared. But for us, it's not a cubed minus b cubed, it's x cubed minus 4 cubed. But it's the same pattern, right? X minus 4, good. Good, right?
X, 3,
X squared, right?
X.
Squared
Oh, and then
Plus.
plus X,
times,
4,
so that'd be just 4x. And then,
plus 4 squared,
which is
16.
16, yeah, so there it is, right? So there's what the difference of cubes pattern gives us for that factor, and then don't forget out front, we've got our x minus 5. And we're done, right? Because we always know that in a sum or difference of cubes pattern, the quadratic one is always going to be done. It's never going to factor more, right? So that's it. That's what we'd input. That's our answer, as far as we can go. Okay, let's try another one. What about this? Okay, this is one, what I just want to show you here is not anything new. I just want to show you that you can apply the stuff you already know to problems like this. Okay, this doesn't seem at first look to match any of our patterns. It's two terms, right? We can't factor out a greatest common factor, so it doesn't seem to match any of our patterns, but we can make it work. Does anybody want to hazard a guess here? Which pattern would work for that? It's a difference, right?
How do you take the, like 4 squared to the 16?
We could. Okay, so the 16, so you're suggesting maybe a difference of squares,
Yeah.
right? So we could write this as something squared minus 4 squared is 16. Okay, well, what would work for the first part? What's going to be, what squared is equal to x to the 4th? What do you think? Valerie, any ideas? What could I square and create x to the 4th? So what's going to go in here? I know, what would be in there? Ah, here it, x squared, right? if I square a square, what does that do? If I take a power to a power, that means I multiply the exponents, right? So that would work, wouldn't it? Then I'd end up with x to the fourth. Okay, so that's the same kind of thing we had before, only this time our a is x squared and our b is 4. This is a really easy pattern though, right? What is our difference of squares pattern? A squared minus b squared.
A minus B.
Yeah, a minus b times a plus b, in any order, it doesn't matter, right? A minus b times a plus b. So what's this one gonna factor into then? What's this gonna be? Who am I calling it? Ellie, what do you think? If I use that same pattern, I've got x squared minus 4 squared. What's that gonna break into? X squared plus 4, right? Because that's what's being squared is x squared times x squared. Already got the plus 4.
Oh,
Minus 4, okay. Good. So that's good. We broke it apart. Now we have to ask ourselves, can we go further with either one of these? What do you think? Lorena, can I make that one break down any further? You can't. You're right, because that's the sum of squares pattern, right? That one doesn't exist. That would be like x squared plus 2 squared, but you can't do the sum of squares, right? What about this one? That one would work how? Tyler?
Square root of 1.
Ah, okay, good. I could write this one as x squared minus 2 squared, right? I'll leave this one alone because I'm already done with that one. But the x squared minus 2 squared, how would that factor?
X squared, or no, x minus 2, x plus 2.
Good, and then this one, we were already done. So that's our answer, right? Okay, so what's the trick? Not much of a trick. You're just thinking of x squared as being x to the 4th. And so I could use, even though I've got an x to the 4th to start with, I can still use the difference of squares pattern. Okay, the same kind of thing you can do right here. This one looks really hard, but it's not. It's no big deal. Is there a greatest common factor?
Yeah.
Okay, what's it going to be? Sir, what's the biggest power of x I could factor out?
2.
Yeah, x squared, good, because they've all got x's and the smallest power of x is x squared. So we can take out an x squared. What number would go into all those? 4 does. Okay, so I could take out a 4x squared, and then to find out what's left over, we'll just divide each term through by 4x squared. Okay, well, what's the first one going to give us? What's 4x to the 6th, Justine, divided by 4x squared? What do you think? What happens to the 4s? They'd cancel, right?
Yeah.
Okay, and then, so x to the 6th over x squared would be, no, not cubed. Remember, if I divide like bases, what do I do to the exponents? If you do, it's been a little while since we worked on this. If you divide like bases, you subtract the exponents, yeah. So this would be, remember I was talking about the x would stay on the top because it's more powerful, and I would subtract the 2 from the 6. X to the 4th, there you go. Okay, what about this one right here? What are we going to get? So 136 over 4. Now, if I want to divide something by 4, I'm just cutting it in half twice, aren't I? Right? What's half of 136? Half of 140 would be 70, right? So it must be a little bit less. What is it? No. 68. 68. So half of it would be 68, and then I got to cut it in half again because I'm dividing by 4. 34. Okay, so we get plus 34, and what's going to be the power of x there? Squared. Okay. And then finally, 900 divided by 4. This will be easier. Cut it in half. What's half of 900?
350.
450.
450 divided by 2. Cut that in half. 225, there you go, okay. Plus And what's the power of x there?
No.
Nothing, yeah, it cancels. Okay, good. All right, so then look what we've got. So that's good, that's very helpful, right? So now we took out a greatest common factor, and what we're left with has 3 terms. We've done a lot of factoring with 3-term polynomials before, but they always looked a little bit different, right? The 3-term polynomials that we factored have always been quadratic trinomials, right? They've always had an x squared and an x and a constant. Right? Can we think of this as being quadratic? For it to be quadratic, it would just have to be in the form, it just has to be in this form. A times something squared plus b times something plus c, right? Well, in this case, so can I do that? Here's my question. Can I make this look like, I want to take this whole thing right here. Can I make it look like a times something squared plus b times something plus c? Can I make it look like that? Say it again? You're kind of pushing in the right direction, but how do we just get rid of a square? Okay, well, all I need to make this thing work is to have numbers for a, b, and c, and have something that's squared here to the first power there and a constant there, right? What do you think maybe the values of a, b, and c could be? I've got these 3 terms. How about 1, 34, and 225? Everybody agree? So we don't have to, that 1 is kind of invisible, right? We don't have to really write that. We don't write a coefficient of 1, but it's there. B is 34, and C is 225. I just need to have something that's squared here and to the first power here. Does this remind you of that last trick we did? Is there a way I could turn x to the 4th into something squared? X squared, yeah, how about that? So what if we wrote this as 1 times x squared squared plus 34 times x squared to the 1 plus 225. Then it is quadratic, isn't it? Right? And if it's weird to look at it, maybe that's visually confusing to see x squared squared. We could even just do this. Just humor me here for a second. We're going to make these, we're going to replace the x squareds with dots. Now it looks quadratic. That's a weird variable, but it could be a variable. So I'll get rid of that 1. We don't even need the 1 there, right? So now we've got dot squared plus 34 dot plus 225. Okay, that could maybe factor, right? That looks like one of the magic number type problems that we tried to do back in Module 3. Well, what would the magic numbers have to multiply to? 225 and add to 34, if it's going to work. Well, let's just see if we can make that work. So then we'd end up with, I'd end up with a dot there and a dot there. We used to have x's back in the old days, right? But they're dots now. And then I'd have to somehow find some numbers that multiply to 225 and add to 34. Well, what are the signs going to be if those numbers exist? Both positive, right? Because they're going to multiply to a positive and add to a positive. So they both have to be positive. Well, let's just see what we can find here. Let's look at factors of 225, because there aren't that many. So I could break it up into 225 and 1, but those add to 226. That's way too big. What's the next biggest factor of 225 after 25? Well, 25 goes into it, doesn't it?
Yeah.
So we could try 25. 25 times what is 225? 4 25s per 100, right? So I'd have 4, 8, and then one extra one, 9. And that's it, isn't it? 25 times 9 is 225, and 25 plus 9 is 34, right? So that's our winner, right? And so we'd end up with dot plus 25 times dot plus 9. And then out front, we've got this 4x squared, and we're done. But it's not really a dot. What is it? It's an x squared, right? The dot covered up the x squared. so instead of a dot, all we've got there is just an x squared. But you see how that worked? If we group this into pieces of x squared, it was the same old kind of trinomial we always worked with, right? If we want to break this apart, the first term times the first term that I distribute has to be an x to the fourth. Well, that would just be an x squared times an x squared, right? And then the rest of the numbers were just the magic numbers we'd always found. So now we have to just ask ourselves, can we go any further? We got this down to 4x squared times the quantity x squared plus 25 times the quantity x squared plus 9. What do you think? Caitlin, can we go any further with that? Did either one of these break down more? It looks like they should. Looks like they should. But what pattern would they fit? They don't, right? Because it would be a sum of squares, wouldn't it? And sum of squares doesn't exist. So this is our answer right there. Okay? Make sense? All right. That's it. That's all I got for you. So you can grab a Chromebook and work.